All right, so now that you have set up Zephyr OS on your host computer, how about we do a simple test to at least verify and validate that the setup you did is working correctly to the extent that it can help us compile our firmware and also upload the firmware onto our target MCU, right? So I'm just going to create a simple project which is supposed to blink an LED. The objective of this video is not for you to understand the code in there. So if you don't understand the code you will see, that's absolutely normal and expected. In no time in this course, you will become a master of every code that you are about to see. So just follow through. I'm going to create a project for STM32F4, but feel free to use any board that you have chosen because hey, this is Zephyr, right? And it works for any of the 800 plus boards that it supports, as you saw in an earlier video. So depending on the workspace that you created, sorry, I have a workspace for STM32 and Expressive. So I can create a project for any of these. I'm going to target STM32. You target whatever board you have available for which you have initialized a workspace, okay? So you come to the applications section, you click on create new application, and then you choose the workspace that fits your target. So mine is an STM32. I'm going to choose this SDK, and my board is an STM32F4 Discovery. So here, so just go through, find what you have. And I'm going to create this based on a template called Blinky. So I'm looking for basic Blinky. So you see why you need a workspace for each target MCU. You can see that my target MCU, I called it my workspace, I called it Zephyr Workspace STM32, and inside it there are samples, and these samples have been built, organized in such a way that the configurations are such that it should easily compile for the target MCU, right? So I'm going to choose this basic. There is the other Blinky that is not from basic. So let's choose, make sure you go to basic and then you choose Blinky. And I already have a project called Blinky, so I'm going to call this Blinky. Why not? And I'm going to browse to put this on the desktop. And I will say select, and I will say create. All right, so at this point, it has created a project called Blinky. But like I said, if you look at the project under the project management section of the Zephyr Workbench, you don't see exactly what you see on your file system. So you can click here and you go to, so all these are open, but this is my target, right? Blinky. I go to src, I go to main.src. Now, do not make it a point to understand all the code that is written here. Like I said at the start of this video, very soon you will be a master of what you see here. Until that understanding has come, so many things will look magical, and that's okay. The objective is not for you to understand what you see here, but just so I help those who want to try to understand, it's basically setting up some pins, GPIO pins, and toggling them whilst waiting this sleep time ms in between. So let's see sleep time ms. Sleep time ms is 1,000 milliseconds, so that is 1 second, right? So we expect that some LED on the board should be blinking on and off every 1 second, right? So how do we build this project and how do we upload the firmware onto the board? Now you have to come to Zephyr Workbench, and the Workbench works based on context, and the context is the application that you have selected. So when I select this Blinky project here, I can click on this gear icon here, and this is what actually builds it. So if you click on this, check your terminal window for output from what the build system is doing. And if you pay close attention, you can see that Zephyr is actually using ST's own tools behind the scenes to compile this project, because we said we are targeting the STM32F4 board, and so it has to use the tools that comes from ST Microelectronics. So this is what I want you to get, right? Zephyr is more like a layer on top of the provider or the vendor specific SDKs that you would have to learn if Zephyr wasn't there, right? So if Zephyr wasn't there and I'm working on an STM MCU, then I have to learn maybe STM Cube HAL or do bare metal. If I'm building for an NXP board, I have to learn something from NSP. If I want to build for a Nordic semiconductor board, then I have to learn the nRF Connect SDK. The need to learn all these many frameworks is what Zephyr is trying to solve. So it's just giving you a set of public APIs for you to use. And these APIs have been designed to unify all the functionalities across the supported boards. However, the code you write in Zephyr will actually be translated into that vendor specific C code, which can only work on their board. And this is why you need their tools. So as you work, you will realize that some things wouldn't work when you expect it to work. And this is where you have to pay attention to reading error messages. I will show you one that I got when I tried to flash onto the STM32F4 board prior to setting up the STM tools that I needed on my computer. And you can see that the error messages are descriptive enough to help you diagnose and also fix the situation. So do not shy away from reading the output here, right? So enough rant already. Now, when it builds successfully, it's going to tell you some statistics about the firmware. So basically, how much of the flash is it using, how much of the RAM is your code or your firmware also using, right? If it didn't work, there will be some red writings here and you know that it didn't work. But once you see this down here, it has worked perfectly. Now, how do we flash this onto our board? You click here. It looks like a play icon. It says run, right? When you click, again, this is where your understanding of Zephyr becomes important. Like I said, Zephyr is not doing any magic without the help of the vendor specific tools that you would need if you didn't have Zephyr. So it has what is known as runners. There are runners specific to the boards that they support, right? So when it comes to ST, for example, I can choose the default, right? If you choose default here, because you created this project using the Zephyr Workbench and you told it what your target board is, it is going to know what runner to choose, right? So if I click this and I wait, it has loaded the code onto my board, and I'm going to switch scene here for you to see what I mean, right? So if you look on the board here, you can see that there's an LED here and it's blinking 1 second apart, right? So I basically have my cable connected to my computer and I have flashed the code onto this. Now let's switch scene back to the desktop. Yes, so as you saw, it has flashed the code successfully and it used the default runner, which leveraged what is known as STM Cube Programmer. If you hadn't installed that, you get an error, and I'm going to show you the error I got when I tried to flash prior to installing STM Cube. So you see, it says West Flash using runner STM Cube Programmer. So by default, because I chose that I'm building for STM32F4, it is expecting that I will have the STM32 Cube Programmer on my system, and this is an actual software, right? So I needed to have to install STM32 Cube Programmer from ST Microelectronics, and I also had to add the path to my path. So it's expecting that this path, the application, blah blah blah, all the way to bin, it should exist in your path, your system path, before it can find it. Now, if you do not want to use the default, many of the boards out there also support what is known as OpenCD. or open on-chip debugger. It's an open source project that also helps to flash firmwares to different microcontroller units out there. So if I click here, I could also look through until I find runner OpenCD. This is installed by default when you set up your Zephyr SDK and you initialize the workspace and all those ancillary things you needed to do before we got to this stage, right? So when I click on OpenOCD, you can see that it is compiling, it is transferring the code onto the board, and at this point it has actually finished transferring the code onto the board. And so again, I'm going to switch scenes here, and then you look at it and you can see that the flash that we did again is working and the LED is blinking 1 second apart, right? So let's switch back onto the desktop, and this is it for how to test and validate that your setup is working correctly. Like I said, don't worry about trying to understand the code that is here. So if you got this to work successfully, regardless of the board of your choice, whether it's an ESP workspace you created, NSP, or Nordic Semiconductor, everything should work. If it didn't work, you can write in comments so that I can also know how best to help you go beyond this hurdle. Thank you very much for watching, and I will see you in the next.